Alright, let's try to do another one of these vector addition problems with these boats. Let's try letter B. And with letter B, this guy, the boat is pushing with its motor at 5 meters per second, all in the east direction or all to the right in the horizontal direction. And then perpendicular to that, the river is pushing down at 2.5 meters per second. Okay, so what we want to solve is the resultant of adding 2.5 meters per second straight down with 5 meters per second straight across. So let's draw the addition of those vectors. So we're going over 5, and we're going down 2.5, and we want to find this guy, that side right there. And we'll also want to know, okay, at what angle is this? Is it 30? Is it 40? What is it? Okay. So let's start doing some addition of vectors. Okay, this is all x, this is all y. So I'm looking for the resultant. That means that this angle right here is a 90. If this is all x and if this is all y, the resultant is that's a 90-degree angle because x and y are 90 degrees to each other, perpendicular. All right, so our resultant, that's a horrible R. Let me draw a new R. There we go. A resultant can be found using, you know it? Yeah, Pythagorean theorem. So 5 squared plus 2.5 squared should equal my R squared. So let me use my calculator. Solve this. Hopefully you're getting something similar to this. Just say 5.6. That's what I'm getting. Rounding it to one decimal place, 5.6 meters per second. So R is equal to 5.6 meters per second. Alright, so we have that. Now to find the angle, well, we can do this a couple different ways, but the angle can be found using the trig identities, and we know the opposite and adjacent side. Yeah, we could use this 5.6, but I like to use the numbers that the book gives you before you start using numbers that you derived. So let's use the 5 and the 2.5. So that's opposite and adjacent of this angle. So I should probably use a theta to represent an angle. There we go. So tangent theta equals opposite over adjacent. Let's plug in actual numbers. So 5 divided by 2.5. So in your calculator, to solve for theta, you're going to hit the probably shift tangent button to get the tan -1. And then in the parentheses, put 5 divided by 2.5. You could just do 2. So let me plug that into my calculator. You can do the same. And I'm getting a answer that's 63 degrees. So, let me check and make sure I got everything right here. Adjacent, we're saying is 5. So, oh, I plugged that in wrong. Okay, Mr. Casing made a mistake. That didn't sound right, so I thought I'd check myself. Let me back up here. Hopefully I can edit that out. Tangent theta equals my opposite side to this is 2.5. The adjacent side is 5. I'm sorry. Now, take tangent -1 of a half, because 2.5 divided by 5 is a half. Plug that into your calculator to solve for theta. Sorry, I had to flip that over. And I'll plug that in. That's much better. We're getting an angle of 27 degrees. If we round to the ones place, in your calculator you might get 26.5, something. So that is the angle. 5.6 was the speed. So if we want to say that, we have to look at the drawing here. So it's down from the horizontal, right? This resultant is down from it. So we need to say that it's traveling at 5.6 meters per second at about 27 degrees below the horizontal. Or you could say 5.6 meters per second at 27 degrees south of east if we had given, a direction here, like this is north, this is south, this is east, and this is west. You could have said that. It's 5.6 meters per second at 27 degrees south of